This assignment is asking us to find all the second partial derivatives. First, we need to find the first partial derivatives. Let's find w sub u. So if we write this original function as u to the 7th plus v to the 9th raised to the 1/2 power, this is going to be 1/2 u to the 7th plus v to the 9th to the minus 1/2 power times the derivative of the inside with respect to u, and the v would be gone. And then w sub v similarly would be pretty close to this. We have 1/2 u to the 7th plus v to the 9th to the 1/2 power times the derivative of the inside, but this time the inside with respect to v is just going to be a 9v to the 8th power. Alright? That's our first step. Now to actually get these things, we get w of u, or w sub u, derivative of w with respect to u. We're going to take the derivative of wu with respect to u, so u is our variable. As you can see, this is going to be a product rule. So let's take the derivative of the first. That is going to be negative 1/4 u to the 7th plus v to the 9th raised to the, you got 1/2 minus 1, so it's negative 3/2 power. So it's derivative first times the second, plus the first times the derivative of the second. So the derivative of this is going to be 42 u to the 5th power. So that's it. I probably wouldn't want to bother simplifying this, so I would just probably try to type that in the way it is. Now let us take the derivative of, let's see, we'll take the derivative of wu with respect to v. So that's the derivative of wu with respect to v. Okay? So this is a constant, so I would just leave that as is and take the derivative of just this part right here. So derivative of that is negative 1/4 u to the 7th plus v to the 9th to the negative 3/2 power times the derivative of the inside with respect to v is 9v to the 8th. So that's the derivative of this, and then now this part here is constant with respect to v, so that's just going to be 7u to the 6th. Okay. Now let's take the derivative of wv, that's this term right here, with respect to u. So if we take the derivative of wv with respect to u, again this is constant, so we need to take the derivative of this with respect to u. And that is going to be negative 1/4 u to the 7th plus v to the 9th to the negative 3/2 power times the derivative of the inside with respect to u, so that's 7u to the 6th. And then, so this is the inside, or I'm sorry, this is the function or the variable, and then the other function over here is actually constant with respect to u, so that's just 9v to the 8th. And it shouldn't be a surprise that these two things are equal, because this is generally a continuous function in its domain, so it's one of those nice functions where the mixed partials should be expected to be equal. And that's there, you will see that they're exactly the same, except the order is switched for those other factors. Alright, the last one, WV with respect to V. So this is going to be a product rule, derivative of the first times the second plus the first times the derivative of the second. So let's go ahead and work that out. Derivative of the first, and you should get used to writing this stuff by now. We're taking the derivative of this with respect to V. So with respect to V, that is going to be a 9V to the 8th as per the chain rule. So that's the derivative of the first times the second. The second is going to be 9V to the 8th. Now we're taking this with respect to V, so this is a variable. Plus the first, 1/2, that would be U to the 7th plus B to the 9th to the negative 1/2. So this is the first times the derivative of the second with respect to V, and 9 times 8 is 72, V to the 7th power. Again, I would leave my answer like that, and so that's the solution. The trickiest part is that you have to apply the chain rule, and you have to keep the chain rule and the product rule separate, and you have to know when you're dealing with a constant. Okay? So I hope that helps with this homework stuff.